arrays are also something you can declare with a literal. Okay, but under the covers, an array is an object. Okay,
Right.
so if you were to say type of this, it's an object. And then, of course, you can call methods on arrays. Okay, so let's see, assign this to R. Now we have 1, 3. Let's say 1, 2, 3. Now you can access this, but you can also call methods. So we already saw reverse. And those methods are pretty obvious. You can access the index of 2. But there are some others that are new, especially if you come from PHP, which are the higher order methods. Okay, those are the methods that let you pass a function. For example, you have map. Okay, map is going to let you pass a function, and what you can do in here is basically iterate through all the elements in the array, this array, and return a new array where each element has passed through this. Now, I'm missing something here. I don't know if you can spot it. This is not going to work. Okay, this is not going to work. Why? So it mapped every element, but it's undefined, undefined, undefined. Because I'm missing the return statement. Okay.
Oh, I see. Yeah.
Everything has to be explicitly returned. But now I'm using map. So map is sort of a predefined function. You could actually write it yourself. That it iterates over the. So it internally it will create an array, then it will iterate over the original array. It will process each element and it will add it to the array, right? And the great thing about these higher order functions is that you're basically abstracting yourself from the flow of control.
Sure.
There's something going on inside. All you do is pass the function that has to be applied. There are many others. For example, you can pass. There's another function. Sorry, that's quite typically used. That's called each, and each also takes a function. The only difference is that this one will not return anything. So you have to produce some sort of side effect in here. You have to do something like log, and we're going to log the element, which is e, console.log e. Okay. So those are the higher order functions. And what happened here is that these are the console.logs, and this is the return value of r.each, which is the array itself.
Sure.
Okay. Those are higher order functions, or HUFs, or some people call them, functional functions, or they're the basis of functional programming. Okay.
Right.
You can create your own. You can pass functions to many other circumstances. Another very common circumstance is when you need to react to an event. So say in jQuery, I don't know if there's jQuery in this page. We had one here, so I'm going to go back here. We have jQuery here. Okay, so I can say $$. That's a universal variable for jQuery, and I'm going to get all paragraphs. Okay. The way jQuery works is it allows you to select pieces of the DOM, and then you can do things with them. So what I did before is I said, for every paragraph in the page, I want you to call this hide, and I hit them. If you look here on the right, on the left, there are no paragraphs, and now I'm going to show them back. But another thing you can do is you can say, for every paragraph, I want you to add a handler for the click event. Okay. So, but how would you express what you want to happen here? And that's where you can use functions, again, anonymous functions. So you can say, whenever this is clicked, I want you to execute this function.
Okay.
So the guy who coded jQuery created this click function, which is going to take this function and is going to add it to another handler, which is basically in the DOM, but it's the same technique. Now I can say console.log, or I'm going to do something more visible here. I'm going to alert. It's going to alert P. Okay, so now every paragraph has an event handler.
Right.
And there you go. So I click and it executes. So those are the most common uses for higher order functions. One is, or for function expressions basically. One is just to recap. One is the higher order functions, to pass them as arguments to other functions, and the other one is to add listeners or to add events, to add handlers or blocks of code that will happen at some point. Okay, and that's a very powerful thing. I mean, that's one of the main features in JavaScript. And on top of that, you can build many other complex things. So I highly suggest you start reading about functions because they're going to be your best friend, and they're going to cause you to hate PHP rather soon because you're going to miss them. Another important thing about functions is that, say you have a variable here, okay, name equals Alex, and this variable is declared here on the global context. But I want to access this down here, so I want to say console.log name, right? This will work, okay, because every block of code can see its own variables, those which are declared here, and those variables of its parent scope. Okay.
Right. Okay.
So this will work, but this, of course, will not work.
Right, because once it's inside the function, it's in scope.
Exactly.
Okay.
If you notice, there's another important thing here. I'm declaring a variable, the var keyword. The var keyword, you could argue that you could erase it from JavaScript, but if you do that, you wouldn't be able to solve this problem here. So what I'm doing here is I am replacing the value of this variable because I'm accessing it here. The difference between this and this is that here I'm declaring a new variable in this scope. I won't be able to see this one. Okay, so this is called shadowing. And in general, you have to be very careful to declare your variables because you could be replacing something that's out there. You're probably not even seeing it. For example, if I were to do this, okay, we could get into trouble because I would be replacing some global variable that's probably attached to window. Window is the global context. It's like the father of all contexts. Okay, those are scopes. Okay, you can have functions within functions. Functions are very powerful. You can do everything that you come up with functions. Another neat part is that each function, I told you, it takes an argument, right? An argument list, sorry. But if you had a function that took an infinite amount of arguments, it would be pretty impossible to declare each one, right? So you have a shortcut. There is an object within the function that's called arguments. An arguments is an array. Okay, it's not an array, or it's not an array or a normal array. It has some specific features, but you can access the first element, the first argument, second argument, like this. Okay, so basically you have infinite arguments. They're going to end up here in this array. You can also test the length, okay, of the arguments array. So you can see how many arguments were passed explicitly to the function.
Sure.
Okay, so that's basically for a, what's the name for this? In some languages it's called a var args. In other languages it's called a, I forgot. There's many names. Okay, now there's an opposite case. So imagine you wanted to pass an undefined amount of arguments to a function. Okay, so imagine you have the result of a computation that you don't know how many elements it has all these elements, and then you have a function that, let's say function sum, and you want sum to take all these numbers and sum them up. You would have basically two choices, right? One is to say, okay, this function sum takes an array. That's probably the easiest one and the most obvious. Okay, but you could also say, you know what? I don't know how many arguments this is going to take, so I'm going to use the arguments array, right? And in this case, you would need to somehow expand this array and apply it here so that you end up with this.
Right.
You end up with the elements here, like without the braces, right? So how do you do that? Well, functions are objects, and they have function. They have methods. So I'm going to show you here. Let's declare a function. It's going to be a very simple function, but now I can see that they have a lot of methods. And one of the methods is called apply. Okay, and function.apply lets you use the function and pass the arguments like this. Okay, you can pass an array of arguments, and what's going to happen in this case is that these arguments will be used as input to function, to sum, sorry, and they're going to remove the braces, which is exactly what we want to do. So if we wanted to call this with like this, right, we wanted to somehow remove and expand them here, we would say sum.apply null and array. Okay, that's what's going to happen. Now, why does it say null here? And this is where we're going to go. We're going to get to another. We're going to jump to another feature of the language. Say you had a person, okay? Var person equals, and we're using an object here. I say person.name equals Alex, and then you add a method, person.hello, and this is a method. Okay, it's a function, but the difference is that you can access the object from within. You can say this, and this is going to be the object where the function is attached to. Okay, so you can say this dot name. You could console dot log this.
Right.
So this is basically the object-oriented part of JavaScript. Still no classes, no inheritance, but at least we have objects. Okay. Now I can call this by saying person.hello, and then when I call this, it's going to work because I'm very explicit on the object onto which I want to apply this function. Okay.
Right.
I want to say call hello on the person object, which is this object here that has this property, and so this context or this variable within the function is going to be defined to be this object. Okay. But I could also say, since functions are are objects, I can assign the function to a variable, and now it's sort of orphan. Now it's not attached to person. It's right here. Then I can call it, and I'm not being explicit. I'm not saying this function belongs to this person because I could be assigning it to person2, right? Person2 the hello. So this is an object, and I say person2 the hello equals h. So now it becomes ambiguous, right? You wouldn't know just by having h which object is the owner of the function. Okay, that is a very tricky thing to understand in JavaScript. It's called the this binding, or I would say it's called the this problem. When you use this, you have to be very careful because you may be referring to any object depending on where the function is called. Okay. Right. Really, it is a very important issue. You have to understand. You have to go read through it. There are many ways of attaching this to a fixed object, but they are tricks. They're not part of the language.
I see.
So we were talking about function.apply. So h is a function. We know that h is a function. We said we declare the function here, or here, and then we assign this function to h. So we know that h is this function. It's this. Okay. Now we want to call function h on another object. We want to call it on, say, a person3. Okay. We can tell function to apply itself to an object. We can say apply to person3. Sorry. When we do this, we are saying explicitly, I want this variable within the function to be person3. So the first argument, which was null here, and you can leave it null, in which case this is going to be the global object. The first argument is the object, and then the variables, whatever set of, the arguments, whatever array of arguments you want to pass. So this thing here would expand to something like this: person3 dot hello 1, 2, 3. Okay. Again, this is very powerful because it allows you to jump one level up. You will find uses for this. So functions are, I'd say there are like 80% of the language. Right. I don't know if they understood that when they built the language, but that's how it is. Right. There is another, what are we missing? We're missing one thing, which is classes, right? Are there classes in JavaScript?
There are objects.
We don't have classes. We have objects, but we don't have classes. we have something else that's called the prototype. I'm going to type something here on a weird language, and it's going to output some JavaScript. But what I want to show you is that this weird language here has classes, and it will compile to JavaScript, and it will create the equivalent of a class in JavaScript. And just so I want to show you that. So if I say class person, we have this weird thing here. Okay, this is how you create a class. You basically create a constructor function. Okay, and so anyway, this is kind of complicated. But you have this.
Right. So that's not an object in the sense. So that's not an object in the sense that it has key value pairs.
This is just a class. I could add, say name. The name is going to be equals to foo. So now I have every class, every instance will have the property. Okay. If you look here, you're going to see that there is this thing here, which is a function, and this function has the name of the class. And then to this function, we attach something to the prototype. The prototype is sort of is an object from where it will inherit all values.
Right.
And that's how you create inheritance. And that's how you say this is an instance of that, is because the prototype is that of which an object is an instance. And it's a bit complicated, okay?
Yeah.
In fact, I just remembered, give me a second. But I don't want to go there because I will probably just confuse you.
Yeah. Yeah. Let's work through some of those coder bytes.
Okay, but now you saw we're still missing the control structures though, which are pretty important. So if you want to see them, I can show you. There are three. You want to see them?
Yeah.
Okay, no, you are the boss. You tell me. What do you want to see?
No, I wanted to go over a few of these.
Okay.
I mean, I'm doing a lot of reading, but I just kind of like to see, how you would go about solving a few of these.
Okay, which one?
Just kind of build out. Yeah, let's do the factorial.
The factorial. Okay. Let's go to JSFiddle. Where is it? Here. Okay. So of course, the first thing you would do is to create a function. It's called factorial, and this function will take a number. Okay. If I'm not confused, a factorial is the factorial of 0 is 1. Factorial of 1 is 1. Factorial of 2 is 1 times 2, right? Factorial of 3 is 1 times 2 times 3. So just by reading this, you can notice that we have sort of a general pattern, but the general pattern starts here, right? Or starts here if you want, which is take the number and multiply it by the previous number and then again, okay?
Sure.
So this, just by reading this, you can see that you have special cases. So let's start there. Let's say, okay, I'm gonna test for my special cases. If num equals 0, then I'm gonna return 1. I know that. That's a given, right? So it's sort of a fixed rule. If num equals 1, I'm also going to return 1. I could do this other ways, but I'm not gonna do it like that. Okay. Now, and here's where you have many options. Okay, how do you implement this? One very simple way of doing it is I can iterate over an array. Okay. Okay. We could return. So let's try and do that. Okay. So we have x is going to be It's going to be 0. I'm not going to use an array. I'm going to use a number. For I equals something, I don't know what. I is less than number. In fact, less than or equal than number.
Yeah. Let's use 9. You can just use 9 as number at the end.
What do you mean 9?
So call number equals 9 at the very end.
You mean here?
Yeah, exactly.
That?
So you call the function on the number 9.
On 9. Okay. So now what you have to do inside here is just add x is going to be we're going to add something to x. We're going to add something, right? Well, what are we going to add here? And so this is the question, right? And then we return x. So we have two things that we have to play there with. One very simple approach, if you're feeling tired and you cannot think about this, it would be to have just to run this many times, and change this here and change this here. Now, the great thing is that we kind of found what are the knobs that we have to move. Okay, so we already isolated them. So let's start. Which would be the number on which we should start? I think.
Oh, I see. Yeah, 9. So let's start at I guess 0, the way you have it.
I think we should start at, okay, so in order to know where to start, we have to see what we're going to do with the number. What are we going to do with the number? One idea would be to do this, that we need I times I minus 1, right? So that will give us the number times the other one, but we should keep on going. I minus 3, I minus 4.
Exactly,
okay?
Yeah.
So this thing starts getting long, okay?
Right.
We can do this, but suddenly I feel a bit tired of doing that. And I have another idea, okay? Let's leave that here. When you start seeing that this thing grows in a progression, okay, there is another way of doing it. We can resort to recursion, okay? Now, we could do this, but I think it's going to take us like 5 minutes or more.
Right.
So let's try and go through another one. If we have time, we're going to revisit that one. Function factorial of number. We're going to use this, which are our border cases. This is called a border case, right? And then we have to find something, the generality, okay? The generality is probably going to be num times factorial of num minus 1. I think so. I'm not sure. I'm not so smart. Why? Because let's do an exercise. So we say factorial of 9, okay?
Right.
We have 9 here. It's going to come all the way down here, and it's going to say the factorial of 9 is 9 times the factorial of 8. The factorial of 8 is the factorial of 7. So it's 8 times the factorial of 7. Right. And the factorial of 7 is, and so on and so forth, until we hit the border cases, right? The first border case is going to be this one. It's going to be 1. Okay? Let's see what happens. What if we say factorial of 9? You know the result to that one?
Yeah, I don't know what it should be. It should be, let's see.
It should be this. That would be like, you could create a function that just appends a band. And that's valid.
Yeah.
That would be valid. Okay. Let's go. Let's close this one. Now we're going to try this. We're probably getting it wrong. So run. No, that's not the factorial. Oh yeah, could be. Can you test that? Or do you have a way of seeing that?
Yeah, I think so. So in
factorials. Tables of factorials. Factorials.
So it should be
362880. Sorry. Oh, he's correct. Oh, there you go.
You got it?
36288. Yeah, you got it.
Yeah, 362880. Okay.
Awesome. So the pattern here, I mean, this is easier than this one, okay?
Right.
It's easier to reason about. It's probably a bit counterintuitive to start searching for something like this, because recursion has this weird name, and you usually feel very safe of using, okay, I'm in control, I created I, and now I'm appending things, and okay, this is more of a programming problem, but in general, what I look for when I'm evaluating if I'm going to use recursion instead of iteration, or instead of imperative control flow, is for a progression.
Okay.
So if you have a progression that ends on a border case, then you start by looking for the border case. Okay, where does it end? It ends somewhere, and then how does it grow, right? Or how does it go back? So that's basically what we did here. Yeah. So you want to try and do this one?
Yeah. So if you were going to use kind of imperative control flow, you would store all the results from an array from 1 to 9 or all the results from a for loop from 1 to 9 in an array, and then multiply them together progressively?
That's one way of going. Now you don't really need to do that, because you can also you can, while you're creating the array, you could be multiplying them.
Mm-hmm.
Okay.
I see.
But you have to keep the previous factorials. So say we have x. How we do this? So we have xs. So we have all the factorials. So this is, I'm going to call this factorials. Okay. These are going to be all the factorials starting from 0 or from whatever. So let's create an array, and we're going to initialize this array to 1 and 1, because we know that the factorials of 0 and 1 are 1. And now we're going to loop over everything starting from 2, I think. And we are going to say that, 1 times 1 is 1, so we don't need to go there, and we could say that factorials sub I is equal to I times factorials sub I minus 1, right? Probably that's going to work, I'm not sure. And then we return factorials sub none. Let me see if that works. I don't think so. I would be surprised. But you never know. It worked. Awesome, man.
Wow.
Yeah. So what we're doing is, well, I don't know how to explain it. We're using an array as basically to keep the state of the previous one. We don't need the whole array. We just need this and this minus 1, right?
Right.
So we multiply back, because the previous one has everything incorporated. Basically, it's a result of all the previous multiplications. Yeah. Okay. So probably I would do this because it's just cooler. It's more. It has a better name. It's recursion. And you can say, and then you can say that you learned this because you use closure or something.
Right.
Right. Or list.
I see. So the closure is in the return where you actually.
I don't know. I meant the language closure, which is a functional language that we're talking about right now. There's no closure here. Okay. What is a closure? That's a very good question. What is a closure? You're going to run into that a lot. The closure is, we already saw it, but it didn't say what it was. Right? This is a closure. Okay, and then here you have console.log A. Why is this called a closure? Because bar B equals B and bar A equals A in the second bar. Because when you execute function, what happens is that there is an sort of a table that is created. This table says that B equals B, and it also says that A equals A. Okay, very simple.
Yeah.
But if you were to do this, then the table would say something else. So why is it called a closure? This here, this is not called a closure. There's no closure here. But if we remove this, then there is a closure, because the table, this table here, will close over this variable. Okay, it's sort of, it sees what's around, and it says, okay, I'm going to freeze this. This is what goes onto the variable table. So now that's a closure. And why is that important? Because you can remember stuff. Okay, the function allows you to remember what's outside itself. It's going to become, I don't know if it's, it doesn't have just one application. It's sort of something you have to understand that you can do with the language, but it allows you to have sort of a snapshot, and you can, if A is declared here, and then you call this function somewhere else, say that down here, and you don't see A, you have no idea, because the function was declared on a library somewhere, right? So this is, for example, this is on foo.js, and now you're using that on bar.js, okay?
Right.
You call x, then you're going to be accessing this variable up here, which is going to be sort of stuck in this, okay? The table, the lookup table for variables is not called a lookup table, it's called the activation object, just to be more formal, okay? You're going to read about that at some point. But that's a closure. Okay, it's a pretty powerful thing, but it's sort of intuitive. It's just knowing. Okay, well, we haven't seen, which is I think is important, and we have. I don't know how. When did we start? Forgot it.
7:30.
Okay, are the control structures. I don't know if you want to see this or prefer to do another exercise.
No, let's see this.
Okay, first control structures, or the first family, are the conditionals. Okay, you have if, and you have if with an else.
Sure.
Okay, and then you have if with an else, and then if. Okay, and that's how and it's pretty obvious, right? So if you have is else if, you have another test here. That's the first if else. Okay, the first one is if else. There's another one, and I think this is the last one, which is called switch. And switch allows you to test for one value, say 5, and then you add. Sorry, I'm not going to test for 5. I'm going to test for a variable, which is really easy. And case 5 is going to, if it is 5, then you go down here and you do this. Okay, so A is 5. Then, if it is something else, then you say, so case 6, you say, sorry, I don't know what, I know why, but let me force it for a second, and I'm going to show you why. Console.log, A is 6.
I see.
But, surprisingly, if you run this, it is going to say both. It is going to hit this one and this one.
I see.
Because it kind of falls through. So you have to do this. Break. And then you have, the last one is default.
Okay.
And then you say console.log. I have no clue. Right? I didn't recognize it. And that's also a conditional, because depending on the value, you execute one or another.
Okay.
Then you have the switch, and then you have looping, right? Looping. And you have 3 different ways of looping. One is for, which have you probably already seen. This is the most typical.
Right.
I meant something, and then what happens next, and then the body. So if you deconstruct this, you have 3 slots here. The first slot is the initializer. Okay. The second slot is a condition, and the third one is sort of the action that happens afterwards. I don't remember the exact name. Sorry. What?
Just the incrementer is what I said.
Okay, yeah, but you can use these for anything. You could be saying, I mean, you don't even have to use everyone. You could do just this. And what this does is it will rearrange these things on say a while loop, which is but the point is that you have to remember, this is what you do first. This is the condition you test on every loop to see if you keep on looping, and after every loop you run this. Usually they use it for index-based iteration. Okay.
Yeah.
But you can use it for anything you want, and you're going to find some pretty clever usages.
Right.
Another one is the while loop. This is the easiest one. So while true, do something. Now this is a very bad idea. It's gonna block forever. Yeah, it's pretty stupid. Don't do it. But you can have a test here. So you can say while person.alive equals true, talk, right? And then this changes. It's not gonna loop again. You have another. I don't know in JavaScript you have that. Do you have do while? This is a problem with using lots of different languages. JavaScript. Do you have the do while? In PHP you have them, right?
Yeah.
Okay, so I'm probably going over things that you know.
I know most of the control structures there, but still kind of helpful.
Where's the I lost the JSP. Okay, now there you go. There is one that you don't have in PHP though. So say you have an object, okay, and the object has keys. It has key 1 is equal to A, and key 2 is equal to B. Sorry, key 2 is B. And you want to loop over the keys. So you would say for K in object, then you would say console.log K, the variable, plus equals plus objects of K. let's see if I got it right. Let's go here. You have object. Yeah, we have object. And unexpected token, because I'm not closing the console.log. But here you are. Okay? So basically, this will allow you to iterate over each key, and then you can do whatever you want with that. In this case, I'm accessing the value.
Right.
Pretty common thing. Yeah, so this is the only different control structure because it deals with keys.
Right.
Okay.
And you can do that in an array too, a for-in loop like that?
Yeah, you could. The problem is that if you do that, I mean, it's going to work, but there are some border cases. Okay, I'm going to try and show you one. I'm going to show you here because we're not going to see it there. For k in 1, 2, 3 console.log k, and then plus we need console.log k. That's it. Look at this. Okay, this is what I want to show you. So the problem is that you access not only the indexes, but you access every member, right? Which is every property and every method. Okay.
Wow, okay.
So that's not a good idea. Now,
yeah.
You can control this by setting these properties to how do you say that? I don't remember. They're sort of hidden. Okay. But that's an advanced thing, and
right.
There are many ways to configure properties and objects, but the problem is that there are many functionalities in JavaScript that are not available on all browsers, so you should avoid them. You should try and keep it down to the minimum. Right. For example, I showed you the map function here, right? A.map, and then you put a function. Well, it turns out the map is not available on every version of JavaScript. It is available on most browsers these days, but if you want to write like absolutely portable code, then you should avoid that, right?
Okay.
If you want to learn about functional programming in JavaScript, which I highly recommend, you should use _JS.
Okay.
Okay. Underscore provides you with you seen it?
Yeah, I'm learning a little bit of Meteor right now. I'm trying to kind of get my head around all that. I guess underscore is front end mostly. It's just a front end framework similar to like Ember.
No, that would be Backbone.
Yeah. Okay.
Underscore underlies Backbone. Underlies a lot of projects. It's a low-level library. You can use it on the server as well. It provides you with, it sort of augments JavaScript with some functional methods and utilities. But it's very popular, and it packs a lot of features.
Wow. Okay.
So you should use it. I mean, I use it for every program. Once you get used to this, you know that you can you can resort to a function in here instead of implementing it.
Right.
So you can iterate. Probably our factorial problem could be solved by reduce. Okay, reduce is a higher order function that will allow you to go over a collection and do something with those variables and keep on adding them or multiplying them. So just so you know that you have this. Okay.
Yeah. Cool.